but we'll just go with it. Okay, we're gonna do a little bit more planning for our Rust DSA series, our new one. I already did one. We're gonna do another one. Uh, Slightly less noob version of data structures and algorithms in Rust. We're gonna start with kind of the simple ones, the easy ones. Not always that easy, but the core ones, and we'll move on from that. I think what I want to do today is decide on the order, and then the other thing I'm supposed to do is write a blog about this, and maybe make some decisions on like where I should write that blog, what that should look like. You're looking at my Stack Overflow history right now. It was the only thing that said Rust in my current open tabs, so I just gravitated towards that. Let's see. Sure, we'll keep the Vec docs up, right? I think we can close everything to the right. There's nothing that I can't find again. That's open there. Okay, I think we're good. I like the idea of starting with linear search. It's really simple, obviously. Going into binary search, still pretty simple, a little bit different. One of the interesting parts of binary search, I think, in Rust is making a generic binary search doesn't really work that well. Unless, I mean, there's ways we could do it, but I'll just show you what I mean. Let me think. It's called lib.rs. There we go. The main problem is that iterators do not have like a performant, like less than ON split or anything. They actually don't have split at all. So pretty much we'd probably just write binary search for vec. We'd just re-implement what I imagine is just call it, do they call it split in Rust on a vec? Yeah, split at spare mute, split off. Okay, is it splice? Is that what I'm thinking? No. Do they not just have like a clear split on a vec? Am I thinking of, maybe I'm thinking of on a slice? That could be it. Like, can you get two splices? That's probably what I'm thinking of. Returns an iterator over subslices separated by elements that match pred, starting at the end of the slice and working backwards. The matched element is not contained in the subsplices. Okay, this is not what I'm thinking of. As with split, oh, I just didn't go far enough down. Okay, returns an iterator over subslices separated by elements that match pred. The matched element is not contained in the subslices. Okay, let's just look at this real quick. Let slice equals slice.split num mod 3 equals 0. You have 10 and 40 and 20. Okay. Oh, that's interesting. I see how they did that. Yeah, that's weird. That doesn't help me very much either. I guess this is like, what, split first, split last, split once? Could be it. Splits the slice on the first element that matches the specified predicate. Okay, this is closer to what I want. Maybe split in is the right thing. Nope. I am a little surprised, and maybe it exists and I just am bad at finding it, but like that there's not a easy, is it just split at and I'm silly? Oh my god. Split at, that makes a lot of sense. I'm just silly. Okay. So this is what I'd want. Divides one slice into two at an index, panics if it's out of bounds, right? You could do split at checked, and what you get a result at, you get a result instead. No, you get an option. Returning none if the slice is too short. That's reasonable. Okay. Anyway. Admiral Entropy, thanks for the follow. I appreciate it. Yeah, so let's see. Where are we at? So my point was partly that like doing this on an iterator isn't easy. Doing a binary search. If we just did it on a slice, actually that would be fine, and that's probably the right interface even over a vec, is to have it on a slice. And then a lot of things could a lot of things implement into slice, so it would be fairly generic. I don't hate that. So this is mostly just talking through some things. So anyway, linear search, binary search. I'm just gonna write down a little bit of this. We're going to do it on I said splice, I meant slice. We're getting there. We're getting there. There's split and splice and slice. There's a lot going on. Linear search, we could implement a couple different ways, but I kind of think just implementing linear search on a slice also, it's probably the easiest thing. It makes sense. Last time we did our little DSA planning, I went over the differences of linear search with a few different algorithms. Basically re-implementing find or whatever, right? Which is on vec, I believe. Where is find? Do they not call it find in Rust? It's so funny how I forget these kinds of things way too often. Interesting. Do we not have a dot find? We don't. Nice. Oh, that's right. Most of those things are on iterators, aren't they? Aren't they on iterators? That's what I'm thinking of. Yeah, that's what it is. Duh. There it is. Yeah, we would probably just do this on a slice. I mean, I get why they do it on an iterator, but it's kind of hard to show it in like a binary search sort of way on an iterator from our perspective. If we're looking for some simpler code. Linked list, I will probably end up writing a linked list very similar to how we did it before. So that doesn't really need a whole lot of preparation. I kind of like going from linear search, binary search, and then into linked list and doubly linked list. I think that's a nice order. Then we'll probably implement a raw vec, like we said here, which will power some of our other things. So it'll power our array list. I think it will make sense for it to power our ring buffer, but I have to think about that a little bit more, because the way that a ring buffer works, of course, is different than that. So we might end up just implementing our own unsafe methods on ring buffer. And that's mostly the point of raw vec, is like, how can we isolate the unsafe parts of some of these data structures? Okay, binary search tree, priority queue, hash map. I actually don't hate the way that this is all here. The sorting algos, it could be nice to look at those earlier rather than later. Where would a sorting algo make sense? Maybe after array list. we might want to do bubble and quick sort. Because then we have an array list. We could even implement it there. Right after binary search, yeah. I don't know. I'm just thinking like, I mean, the thought is like we've built our array list and then we're like, okay, how are we going to sort this? Obviously we can like implement sort on our array list that we just built. That's kind of the idea. I don't know. Does that sound good? You like that? And then the rest of these are a little bit more. I actually think putting a queue right after doubly linked list makes sense because it's like an obvious. It's an obvious use case for a doubly linked list is a queue, like a FIFO queue, right? Doubly linked list. We have a FIFO queue. That's pretty nice. And then ring buffer, binary search tree, priority queue, min heap, hash map. I think all that's good. And then decide if we want to get into some harder stuff. I made a couple purchases I'm kind of excited about. Maybe they will help me explain some of these things better and understand them more deeply myself. We'll see what happens. Let's see. What's the easiest way to get there? I guess, what is it called? Manning? There we go. Manning. So I bought 3 books at Manning. One is just a Rust book. I bought Rust in Action finally. I thought it would be fun to go through the systems programming side of things and maybe learn some things now that I already know Rust. That I, problems I wouldn't normally solve. No, I haven't bought a Glove 80 yet. Maybe, I don't know. I don't know when I'm going to do it. I was like all ready to do it a couple months ago. And then I'm like, I'm fine for now. Maybe I'll do it for Christmas or something. Be my self gift for Christmas. We'll see. Or my birthday, which is in August. So yeah, I bought this book, which I'm pretty excited about. And we'll see if it's any good. It might not be. You never know. So obviously, like, it doesn't do a whole lot of basic data structures because that's the whole point of the book. But it's kind of hits a lot of these same things that we're doing. And then, expounds upon a bunch of stuff that I already know. So there's improving priority queues. Okay, I know what a priority queue is. I don't actually know what a D-way heap is. Treeps, no idea. Using randomization to balance binary search trees, never heard of this. I think that's very cool. Interested in that. Bloom filters, again. Like I know what a disjoint set is, but like I've never done it. Obviously, we know what a try, whatever. I say try because at least, even though some people say it's not correct, at least spoken, you know the difference, right? Perhaps it should just be pronounced tree or trie. Should we call them triers? I'll have to decide because I might actually, I'm probably going to do a trie on stream after the basic stuff. Not completely sure what a radix trie is. Use case LRU cache. I think that'll be cool. Multidimensional. I pronounce it prefix tree. That's actually usually what I do. F collector is because I don't want people to be like, no, it's a try. You mean a try? Because I've done it before, and people are like, you mean a try? It's like, no, you're not really supposed to say that. Yeah. We can only call it a tree A if it was created by a French person. Yeah, nice. So many fist fights avoided. Yeah, hilarious. Some multi-dimensional queries, KD trees. Again, I don't actually know what that is, but tech support is excited about it. So I think this will be really cool. I'm really interested in this book. I'm hoping it'll kind of like next level some of my data structure knowledge. The other one I got is something that's been popular for a while, but they just came out with a second edition this year, like literally in February. And what's up? You don't like those? Yeah. And yeah. So I never bought the first edition, and there's a lot of people that say this book is good. So we'll see. We'll see if I agree with those people. Doggo is in the house. So we'll see what happens. Maybe this will also just help me explain it better as well. Let's see. The revised second edition contains brand new coverage of trees, including binary search trees, balanced trees, B trees, and more. Very cool. That's neat. So that one I'm pretty excited about, and then the other one is Rust in Action. So yeah, it's probably is, but it never hurts to see like how someone else explains it, right, Scott? Like, not that I won't know like the basics of what they're saying, but it's nice to have visual representations, and I'm pretty good at visual learning. So I think that would be cool. Rust in Action. That would be such a great book to write. I don't know what it would be about, but it's a great meme. Either way. So yeah, I'm excited about that. Maybe that will also help me with both explaining some of these things, writing the blogs, etc., etc. I guess that's the thing that I kind of want to think about a little bit, is like what do I want to do? Now, most of the time when I decide I want to write something, I just use write.as because I like the interface, very privacy centric. We can even make them completely anonymous posts, or I can like create a blog that's named and has a URL. I can of course like point it. I've never bothered making a personal website because I just haven't found it to be extremely important to me, and it's so easy for things like that to get out of date, and then you have to maintain them. Resting constipation. Oh no. So we'll probably just do write.as. I don't think it really matters that much, honestly, where I write. And they just use Markdown. It's good enough support. Maybe it's not like perfectly beautiful. I mean, I think their interface actually is really nice, and it's a nice site to read on. So I will probably use write.as, but of course, like a lot of people like the runnable code and easy to copy code snippets and stuff like that. I don't know if I care that much. I don't know if I care that much about pandering to the people. I think the part that I was thinking about this in the last couple days, the thing that I'm not like completely clear on, because the whole point to me, like this part is really important to me for this, which is finishing an actual data structure in a single stream. Some of the time that might not happen, and that's okay. Like, I don't want to be like crazy about it. Maybe it will end up being 2 streams, but if I say it's 2 streams now, then it's going to be 3 or 4 streams, you know? But if I say it's 1 stream, then most likely we can do it in 2 streams. because most of the time I can only stream for two hours. So part of the thing with that I'm not sure what to do. I guess this is motivation. Yeah. Okay, so we'll put this under concerns. Sure. Chat distracts me. It's mostly a joke. I think my concern is that I also want to explain some of what the data structure is for those who don't know. Maybe I need a time limit on that at the beginning of vid stream. I don't know. Anybody have opinion on that? Just like some of these data structures take a while to explain, but maybe it is just like a 5 minutes. This is the basic idea of this data structure. And as we code it, you kind of learn the rest. We don't have to take a long time explaining what the data structure is, because sometimes I will get distracted by that. So what do we want to say? Maybe 5 minutes? Five, explain the data structure in 5 minutes. Now, this is where I'm kind of wondering though, if I don't want to write the explanatory section of my blog post that I'm going to eventually write for the implementation, like beforehand, right? So then that's kind of where it's like, maybe these notes are so good. Maybe it makes sense to write the explanatory introductory section of the blog before stream. I might also do that on stream, but not the same stream that I'm doing the data structure. And then when it comes to actually implementing the data structure, it's really simple, because the kind of format, if you will, I guess we'll put it here. I'm kind of repeating myself now. 5 minutes reading, explanatory reading, introduction of blog post. No, I'm not actually writing Erlang. We watched an Erlang video earlier that was very worth watching, by the way. It was very important. Let's see. That doesn't help me, does it? There it is. Just for you, Prev. I'll find the link and post it. There you go. No, we're doing Rust. I mean, right now we're writing English or something close to English. But so yeah, I think format, 5 minutes reading, introduction of blog post. I think this is why it wasn't worth doing this. Lesabatsi, thanks for the follow. Yeah, I'll probably also post the VOD, a little segment of watching the video on stream as well. I don't know how I mean, it wasn't anything amazing, but this is English V5. Yeah, it's English V5 where we can actually put in comments and trailing commas. Jokes. Hey, 6412. Have you never followed me before? I mean, this is getting a little awkward, but is this the first time you followed me? That's hilarious. Well, thanks. Thanks for the follow. With international extensions, yeah. I mean, English, modern English would not be much of a language without its international extensions. That's for sure. Hard fork to English++ for sure. Implement the data structure. Okay, really glad we wrote out this format section in less than 2 to 3 hours. I guess saying in less than 2 to 3 hours doesn't make sense. Implement the data structure in less than 3 hours, hopefully. This won't apply to like the harder stuff, but I think the only one that I'd be a little bit concerned about potentially is binary search tree. They're not that hard, but I think I'm a little bit concerned about binary search tree. I know last time it took me a really fucking long time. Are we going to make an attempt at a radix tree? Maybe. Them mode, okay. Well, evil mode. Come on, 6412. Come on. We're in evil mode. Yeah, basically that is I am not using org mode. One of the main things that people love about Emacs I've never used. I mean, I tried it a couple times, so I was like, no, I'm not going to spend time learning this. But I know, probably to my own detriment. Sinful to use evil mode in Emacs. Yeah, it is. You could look at the mat chit crate. What is this? What are you talking? Ninja, what are you on about? What are you on about? This is just a router. What are you talking about? Oh, because they implemented a radix tree in order to do their router. Yeah, there it is. Yeah, very cool. Huh. Ooh, that's really good to know. Random stuff. This is what all my notes devolve into. Use a radix tree in router. Okay. Let's see. Binary. What were we just talking about? Oh yeah, implement the data structure in less than 3 hours. That's really the whole format. No. I guess pre-stream, but still possibly live. Write intro blog. Write intro of blog post. And then that way we've already done the intro and we just go ahead and read the intro, explain the data structure. It shouldn't take that long because I'm not doing original thinking. All my thinking is hopefully done by that point. and then we can just implement it.
Me and Emma are going swimming.
Okay.
Foxy needs to go out at 3:30.
At 3:30. Okay.
We might be back by then. I don't know.
All right. Have fun. And then there's that. Okay, cool. Writing an AVL train in Rust in 5 minutes. That would be something, wouldn't it? That's funny. So let's see. Oh yeah, absolutely. I mean, some of these things you can't even do without unsafe. And I mean, you could do them if you cheat, right? Like if you use a vec under the hood in order to implement an array list. Or, you know, you could use what? I guess you could use a vec. Yeah, you could use a vec under the hood of a ring buffer, but that's kind of cheating. It kind of defeats the point. I mean, it doesn't mean that these are going to be the most optimized, amazing data structures ever. You know, this is me we're talking about, but we'll definitely write some unsafe. I think that's also what makes it fun. That we're willing to jump into the unsafe instead of just kind of write wrappers on data structures. You know, write wrappers on vec or whatever. Are they going to be generic? Some of them will be. I mean, they'll be generic in terms of value, but yeah, which I guess is probably your question. Like, we can look at a couple things that I've done before. So, like, this is essentially what our raw vec is going to look like. It's going to be very close to this. Like this, I ended up, you know, it's just a basic stack. And it's a stack over T, right? And that just has pop and push on it. And it's all unsafe. Everything's unsafe, basically. So yeah. That's kind of the idea. Okay. But some of the things are annoying to implement generically as far as the container goes. So it will just depend on whether, like, as far as the algorithms go, like we were talking, that's what we already talked about, is like the linear and binary search is annoying to implement for kind of anything besides a slice. Even though I've done it for other things, at least the linear search. And we could do it for like other things, but then you're basically like creating iterators and then collecting iterators like a bunch of times just to make binary search work, and that's kind of dumb. Let's see here. Is there anything else that I really need to think about for some of this stuff? I guess what might be nice to know ahead of time is what is that website called? I used it a bunch last time. Bookmarks folder. DSA. Here we go. This should be it. Excellent website, by the way. Very, very fun. Let's see. Algorithm visualizations. Let's see what we have. You have a stack array implementation, linked list implementation, queues. Yeah, for sure. That's the goal, at least. Help me refresh on a lot of this stuff too. Let's see. Binary and linear search of sorted list. Okay. Binary search trees. AVL trees, radix tree. They have almost everything in here. Comparison sorting. Oh, that's cool. Anyway, I really like this website. It's like really old school, and it's just like done by people at like USF, but I really like just how simple it is and old school. I used this quite a bit before to like understand some of the algorithms I was implementing that I wasn't as familiar with. I'm just interested in like yeah. It's like so simple, but it's like so helpful to see. Like the actual being able to visualize the algorithm is very cool. Okay. Let's pause. How can we do this? Skip back? No. Okay. Okay, I can go back to here. And we can then look at quick sort. And we can play. Nice. It's funny how little it shows that it's doing anything. Like at first. It could have just been because of the values. Cool. So yeah, I like that website a lot. We'll probably use that still. And it seems like it has basically everything that I want. So that's cool. I don't know. I don't think there's a hell of a lot. Nope, I didn't mean to click that. I don't want you to open Chrome. Stop it, Emacs. No. Why did you take my click as being something I actually wanted to open? All right. I'll go viz here. Yeah, I don't think there's any other prep I actually needed to do. I thought I had a lot more to figure out, but I think that I have most of it figured out, which is probably not true, but we'll just pretend that it is. So I think I'm done thinking about this. We'll